Hey, my early arrivers. I'll get things rolling as I typically do right at 3:45. So in the meantime, if there's something on activity 21 that you want to ask, want to talk about, well, questions on anything, I guess, start getting those questions in the chat. We'll get started right at 3:45. As I recall, my 215 class, we worked pretty well through this whole activity. And it took maybe a little less than an hour. So it usually goes a little smoother the second time because I've been through it once. Uh, so whatever questions you have, start chatting the questions out. And once 3:45 comes around, I'll be ready to go on the first question. Looks like it's time to go. Welcome to the 8 of you. Question 4 and question 1. Sure. Start with question 4. That was sort of the more applicable for today's quiz. On today's quiz, I'm going to give you a definite integral inside a word problem or two, and then ask you to tell me what it represents. So we have a graph, and here's the pay rate. And it's in dollars per hour. And here's the number of hours worked. And notice my grid is set out 40, 80. So I'm assuming, I'm not sure if I mentioned in the problem. Yeah, each work week is 40 hours, sure. So the first week, by the way, goes from 0 up to 40. So there's week 1, there's week 2, week 3, week 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think it was a 15-week thing. So when that worker's put in 15 weeks, she has accumulated 800. And it's one of those functions that keeps increasing, and it's concave up. It's the best of both worlds, I guess. What does 1 square, find the initial pay rate? Okay, I'm going to write the formula. R of t is the pay rate, and it's 6 plus 8. E to a small incremental growing function, double 0, 1 t. So the initial rate, that's what the pay rate is the moment that worker starts working. That's after that worker has worked 0 hours. Calculate R of 0, and you get 6 plus 8, or 14, and that should be that point right there on the graph. Include units. Well, these pay rates in dollars per hour, so I guess it'll be $14 per hour. That's part 1. Or part A. Let's call it part A, shall we? Let's see, part B. What does 1 square area of the graph under the curve represent? And here's where we just really have to get this understood. And once we do, man, this just goes so easily. So there's the square. It's $4 per hour tall and 40 hours wide. So that 1 block of area under there would do the multiplication, $4 per hour times 40 hours. That 1 block is $160. So if you look at, if you want to calculate what you made in that first week, it would be all the area added up from 0 to 40. So every time we're talking about area under the curve, it's the number of dollars that that internist has made. Every time you look at the curve, that's the pay rate, the number of dollars per hour. And those are the 2 things that every question in this section deals with. It's either the total pay is area under the curve, or it's the pay rate, that's the curve itself. How much money did the interns make during the first 3 work weeks? That would be, I guess, week 1, week 2, week 3. That would be out there. And how would you find how much that internist made? Tell me what we would do. Ryan, I like my coffee. I like it many different forms. I don't have a favorite. And yes, we can do problem 3. So how am I going to calculate the total number of dollars that internist made in the first 3 weeks? And if you can understand this question, that's going to help you on today's quiz as well. So how do we? How do we calculate what mathematical expression, first off, is going to give us that? And those of you just tuning in, we're on problem 4, part C. The question is, how many dollars is this intern going to earn during the first 3 weeks? How would I calculate that? Once you have that down, then really everything else in this problem is going to flow pretty quickly, I think. By the way, today it's tea, and today I like it hot. It's freezing up in my little recording studio. It's on the northwest corner of the house, and it's a 100-year-old house. So this room is definitely the coldest of all of them when the wind's in this direction. Still waiting. How are we going to calculate the total number of dollars earned? How do you calculate dollars earned? I guess I could approximate it, maybe. I could look at these first 3 weeks. First 40 hours, she was making about 14 an hour. Next 40 hours, making just a little bit over 14. Next 40 hours, about a 14 more. Let's see, that'd be 560 a week. 560 times 3, about 1680. That would be my bet. But the thing is, she's not earning a solid 14 all the way across. That pay rate is going up. So how am I going to figure out exactly what that amount of pay is? What do I have to do calculus-wise? Or tell me what I would look at as far as the graph is concerned. This is just a huge takeaway. Once you get this stuff down, the rest of it's easy. She was earning just a solid 14, getting no raises. So we draw that nice little square in there. $14 tall, 120 hours wide. But there's that little bit of pay raise that's built in that's going to earn our internist a little more money. How are we going to figure it out? It's 14, a little over 14, a little more than 14. Give you a little hint on the very beginning of the problem. Area of that rectangle was $160. How can I use this information, looking at the graph, come up with the exact number? Well, let's go to the nearest dollar. What can I do to get that, the value for how much money that internist has made? What do I do with my graph, or what do I do with my pay rate to figure out what the pay is? Remember again, this is the pay rate. This is how the pay rate, this is how the pay rate changes per hour. This is the number of hours worked. Dollars per hour times hours gives us dollars. What must we do? Yeah, taking the antiderivative is going to help. If I drew a line straight across here, and of course that should sort of make sense, right? That's what we've been doing. If I draw this line straight across here, I can calculate the area under the curve, and that area under this straight line in this rectangle here, that's the 1680. Okay, but there's more area under the curve than that rectangle allows us to calculate out. What we need to do is calculate the area under that curve. And how do we calculate the area under the curve? It certainly is going to involve an antiderivative. Taking the antiderivative is going to help, but it's more than that. We need the area under the curve to take into account that little bit of extra amount of money that she's at the end of the third week. You know, it starts at 14, raises are built in consistently. So what exactly are we going to do? Taking an antiderivative is a small part of it. Let's work on our language skills a little bit. Total area under the curve here. How am I going to calculate the area under the curve? I think we're on our third day, maybe at least our second day of area under the curve. How do we find the area under the curve? calculus idea allows us to calculate the area under a curve. Totally stuck? Google area under the curve, calculus area under the curve. See if they give you a idea what that phrase is. Two-word phrase. What are we going to use to find the area under the curve? Want to come up with a number after all. What have we been working on that always results in a number? Definite integral it is. All right, definite integral. So we're going to definite integral from 0 to 120. That's the area under the curve. And then inside of this will be our pay rate, 6 plus 8e to the 0.00. Whoops. Get enough O's in there, Andy. 1 t dt. That's the expression. That'll allow us to calculate it. Were we supposed to calculate it? I'd forgotten. How much, yeah. How much did she make the first 3 weeks? Oh, let's figure it out. Well, we'll need an antiderivative. And there's one student in, I think, in each of the classes that didn't bother with the antiderivative, just plugged the number at the top and the bottom in. That's patently 100% incorrect. And I can't give any credit at all for that. This is a calculus class. You must do some calculus. It's not plug in the top number and plug in the bottom number. That would be the difference in pay rate. That's not what we're asking. We need the area under the curve. You must take an antiderivative. Well, antiderivative of 6 is 6t. And here we have that familiar problem with e to a power. So we'll do that the same way we did before. We'll keep the 8, we'll keep the e to the 0.001t, and then we'll multiply by the reciprocal of the derivative of the power. Okay. So if I do that calculation slowly, I get 6t plus 8,000 e to the 0.001t. I'm going to evaluate that between the hours of t equal 120. Whoops, ran out of room there. That's 120 and t equal to 0. I'll do the bottom number. Someone else do the top number. So if you have this function and you plug in the 120, you plug in the top of the borders. I'll plug in the bottom one. If I plug in 0 here, I get 0 plus 800 times e to the 0. I'm sorry, 8,000. So then that bottom number results in an 8,000. So it's going to be some number minus 8,000. And I remembered from just a second ago, would that come out to be 14 times 120? 48. This came out to be 1680 when I looked at that at the rectangle that started 14 high. So I'm expecting a number at the end of this that's slightly bigger than 1680. 9739, I like it. 9739, subtract the one from the other to the nearest dollar, $1,739. So that pay raise is already kicking in a little bit. If she's just stayed at $14 an hour for the first 2 weeks, been 1680, made an extra, what, $59. All right, now we're moving. Now that we understand the area under the curve is a definite integral. How much money got that one? What was the average pay rate for the first 3 weeks? Well, she made this many dollars in 120 hours. So that will tell us the average pay rate. And of course, it has to be a little bit more than 14, right? 14 was the minimum and it shot up a little bit during that first week. So whatever number that comes out, that's definitely the area. The area, definitely the average. And notice the average here is going to be measured in dollars per hour. The average of any of these areas under the curve, the average value of a function is always measured in whatever units the original function is measured in. This was measured in dollars per hour. This will be measured in dollars per hour, and it should be more than $14 an hour. Not all that much more, but a little bit more. Make sense? I'm hoping. What does the area under the shaded region define? So it goes from 240 to 520. So I'm going to shade that region. Just approximate. So someplace along there. It's 240 out to 520. So first up, that area under the curve is going to represent what? At 14.5. Okay, thank you. So that area under the curve is going to represent exactly what? The area under the curve from 0 to 120, that was the total take-home pay for the first 3 weeks. That was that area under the curve. What's the area under this curve going to be? Well, first off, let me get the weeks counted. So before I get to 240, let's see, I'm going to open up my screen so I can count them a little better. There's 1, 2, 3, 4, 5, 6. There's 6 weeks. Weeks 1, 2, 3, 4, 5, 6. There's 6 weeks before we get to hour 240. Right, 640, okay. So let's count that. The rest of the weeks we have in there. Week 7, 8, 9, 10, 11, 12, 13. This week 7, 8, 9, 10, 11, 12, 13. Okay. So what would you say that area under the curve is? And again, we have to get our counters straight. Week 1 goes from 0 to 1. So that 240, that's the end of the 6th week. So what would that area under the curve represent? How much she made between week 6 and week 13. Well, week 6, here's week 6. Week 6 was before she got there. So it's how much she made from week 7 through week 13. 7, 8, 9, 10, 11, 12, 13. Those 7 weeks. Okay? No, it's not the hourly pay rate at all. The hourly pay rate would be variable. The hourly pay rate at week 7 is here. The hourly pay rate at week 13 is there. That hourly pay rate is always changing. The curve is the hourly pay rate. The area under the curve is the total number of dollars earned. Okay? So make sure you have that understanding. That's the big takeaway. Okay? So this is the total number of dollars earned from the start of week 7 through the end of week 13. That would be a good way to say it. Again, pay rate is the curve. It's not the area under the curve. What does the area in the shaded region, that's what I got done. What does area under the curve represent? Oh, under the whole curve. And what does the area under the curve represent in the context of this problem? It's the total number of dollars that our intern has made in that 15 weeks. So let's calculate out what it would be. The area under the curve has a starting destination 0, an ending destination of 600 hours of labor on the internship. 6 plus 8 e to the 0.001 t dt. We've already taken the antiderivative of this once. No sense doing all that work again. Let's evaluate that, and someone with a calculator help me out with the first number. 600 hours from 0 hours. So that's the total area under the curve. I should have put the word total in there. So someone plug into 600, tell me what you get. I'm going to plug into 0. I know it's going to be minus 8,000 because I've done this before. So we're working on part G now. So what do I get when I plug in 600 for my upper limit? $18,176, okay. And let me check one thing here in the answer key someplace. Yep. Subtract those out. Looks like she made about $10,176. I rounded up $1. I'm not sure why. You might want to check that out. Make sure that your rounding is correct to the nearest dollar. Let's find the average pay rate. Well, she made this many dollars, worked 600 hours. Let's calculate what that average pay rate should be. And I think when my last class did it, I think we got around 17 something. I have a calculator button here. I might as well use it. So she made 10,136 in 600 hours of labor. Almost $17 an hour. Okay. Now here's where this is going to hopefully all make sense. So the average pay rate, if you look at the graph, she started at 14 at the very beginning, and at the very end of her 40 weeks, she was a little bit over 20, 21, 22 range. So that number I just calculated, that almost $17, that would be right across there. That would be the line that would show the average pay rate. Average pay rate is written as in the same units as my units were on this axis. So it's almost $17 an hour. If you want to do a calculation for it, that would have been the calculation, right? That would have given you the total number of dollars. That would have divided it out into 600 equal hours. So if you see something like this on today's quiz, you should realize that that has the same units as this, and it's average whatever that curve is. Does Arian got that? Be precise with your units. Is there anything else on this one that I missed? Oh, explain what 80 to 280 means. All right, so I should probably put my weeks back out here again. So 80, there's 80. So we're talking 80, 280. Okay. Look at my picture one more time. So let's see, that's the start. So that'd be the total pay from weeks 3, then I'm going to count my weeks 3. Forgot where I was going. Was it 280? Yeah, through 280. I'm going to count my weeks from week 2, 3, 4, 5, 6, 7, 6, 2 through 280. 3, 4, 5, 6, 7. Yep, week 3 through 7. So that would be the last part of that one. And it gets so complicated because the first week starts with a 0, so we always have to back off from that a little bit, right? So that pretty well takes care of all 4. Area under the curve is the pay. The curve itself is the pay rate. Notice the antiderivative Yeah. Antiderivative is always those units times those units. Phew, that was the longest one. And the rest of them are just a bunch of doing some calculations and figuring out the area. I know we're supposed to do number 3 and number 1, huh? So I think number 1 was requested first. Let's go back to problem number 1. Problem number 1 is, of all of these, takes the most work. We're given 2 functions, and only 2 functions, and we're asked to find the area between those 2. So there's no left bound, right bound, there's just 2 functions. Let's see if I can remember what they were. One of them, the f function, was x cubed minus 6x squared plus 9x, and the g of x function was simply x. Now I have a little bit going for me on this function because I understand what the graphs of these look like. An x cubed graph usually looks something like that, with or without the up and down part. Sometimes it doesn't have a descending and ascending part. And this one, of course, is just a straight line with a slope of 1. So more than likely, if there is an area between these 2 curves, they're going to have to cross someplace. So I'm going to see if I can find 1 or 2 places where they cross. If they cross in 3 different places, then I'm going to have a couple different areas to calculate. If they only cross, maybe it goes something like this. Whoops. Maybe it goes something like this. If they only cross in 2 places, then there's just a single area. So the first thing I need to do, either with a graph or without a graph, is find out where they cross. If you have a calculator or a graph sketch machine, you can sort of make sure that you get this right. Always important to do so. But I'm going to set these 2 equal to each other to find out if they do actually intersect. So to find a place of intersection, write this down. You set the one function equal to the other. That's always the way that we find points of intersection. Well, this is a polynomial. Let's set it equal to 0 and see if we can solve from there. Subtracting an x from both sides yields that. Factoring an x out yields that. And then factoring this trinomial, it's a fairly basic one. We need an x and an x, 2 minuses for sure. And then we need to find 2 numbers that multiply together to give 8, but add up to a 6. That would be 2 and the 4. Setting each of these equal to 0, we get x is 0, x is 2, and x is 4. So these 2 functions cross twice. So I'm going to figure out exactly what this graph is going to look like. Let's see, they look. Kind of make them cross at the right spot. I guess it's got to go something like this. They cross at 0, they cross at 2, and they cross at 4. And you don't have to know the graph. It doesn't make this problem that much easier, but it does give you a little bit to rest on in case you've messed up. Okay. Just to make sure these are right, what I do is I plug in f of 0 and make sure it's equal to g of 0. Plug in 0 here, I get 0. Plug in 0 here, I get 0. Aha! So one of the points they have in common is that point right there, 0, 0. I'm going to, again, check my work. I'm going to calculate f of 2. F of 2 is 8 minus 24 plus 18. That's what? 26 minus 24. It looks like that's 2. And if I plug in a 2 here, g of 2 is also 2. Good. So they also cross at the ordered pair 2, 2. And then I'll plug in 4 just to make sure. If I plug in a 4 here, 4 cubed is 64. Minus 16 times 6 is 96. Plus 36. If I add those up, I get 4. And g of 4 is also 4. So they have 3 points of intersection. 0, 0, 2, 2, and 4, 4. Great. Okay. Now, since they have 2 points of intersection, there's going to be 2 separate areas to look at. Call that one a sub 2 and that one a sub 1. And the total area between those 2 curves then will be whatever the sum of those 2 individual ones are. So let's work with A1. I'm going to work A1 all the way through, and then I'm just going to leave the setup on A2 and let you figure out what to go from there. So as you hopefully picked up from the last video, To find an area between the curve, we always go from lower limit to upper limit and take the equation of the upper function minus the equation of the lower function. So let's do that. So going from 0 to 2 of the upper function. Now we need to figure out which is which. If you don't have a graph, choose some number between 0 and 2, calculate f of 1, and calculate g of 1, and see which one has the bigger y value. If I plug in g of 1, I get 1. If I plug in f of 1, I get 1 minus 6 plus 9. I get 2. Is that right? No, it's 4. Okay, there we go. That looks better. Couldn't subtract there for a second. 4 is definitely bigger than 1. So this f function is the bigger of the two. I will write it out. X cubed minus 6x plus, 6x squared plus 9x. Bigger function minus smaller function, and follow with the x. Bigger minus smaller. Okay. Let's do some algebra before we do the antiderivative. 0 to 2, x cubed minus 6x squared plus 8x dx. Straightforward polynomial using the power rule. 1/4 x to the 6th minus, let's see, raise the power by 1. Reciprocal of the new power, 6 times 1/3. Same thing on the next one, 8, keep the x, raise the power, reciprocal of the power. And if I make this look as pretty as I possibly can, it's 1/4 x to the 4th minus 2x cubed plus 4x squared. So there, I've done all the work on the antiderivative. All of those use the power rule. I'm going to evaluate this from 2. I'm going to let you do that. I'm going to evaluate it from 0, and then we'll take the difference between the two. So evaluate this at 2. Someone grab out the calculator, tell me what you get. I'm going to do the bottom one because it's easy. If I plug in 0 here for x, I'm definitely going to get 0. That was simple. So what do you get when you plug in 2 back into this one for x? Yep, it is indeed 4. 4 minus 0 is 4. So that first area has 4 square units in it. Now we're going to go for a sub 2. And I'm not going to work this one all the way through. I'm going to leave the details up to you. But the setup is similar. The first one went from 0 to 2. This next one is going to go 2 to 4, the next place where they crossed. So 2 to 4. Now I need the upper function minus the lower function. The obvious choice between 2 and 4 is the number 3. So let's calculate f of 3 and g of 3. G of 3 is easy, it's 3. F of 3, I've lost my function. Let me rewrite it. G of 3 would be 3 cubed minus 6 times 3 squaredness plus 9 times 3. So that's 27. 9 minus 54 plus 27, that's equal to 0. And I knew it on my graph. I knew the linear function was bigger than the third order polynomial. And this just verifies it. So if you don't have the graph, here's what you do. Plug a number between those two, see which is the bigger. So now we go bigger function minus smaller function. We'll go g minus f. And there's a little more technical work on this one than there was on the previous one because of that subtraction sign. And here we have 3 terms. So again, I'm going to make sure I do all my algebra first. Subtracting x minus x cubed plus 6x squared minus 9x dx remembering to distribute the minus sign through. Combine like terms, 2 to 4, let's see, those two are the only like terms I have. Negative x cubed plus 6x squared minus 8x dx. And if you look over the one that we did just a second ago, I'm going to rewrite it. It's same terms, opposite signs, right? This is the one we just got done doing when we found the area of a sub 1 was 4. Notice how these two compare. They should be just the opposite because we've subtracted in the opposite order, okay? Negative, positive, positive, negative, negative, positive, yeah, they are. So you should be able to come up with the antiderivative of this one, plug in the 4, plug in the 2, subtract the 1 from the other, and then calculate that second area, whatever that comes out to be. The total area then will be whatever you got on your second part plus the 4 that we had before. So if someone would like to work through the antiderivative of this, evaluate it at 4, evaluate it at 2, and let me know what the second area is, and then we can finish this problem up with a known solution. Okay. Another way of working this one would be maybe to consult Wolfram Alpha. That's a great online resource that would be able to confer whether or not you have the right answer. Okay, Matthew, was the negative 4 when you were plugging in the values, or was that the value you got after you did the subtraction? Yeah, I got a sub 2 is equal to 4. So check your arithmetic through here and see if that one is 4 as well. That should be how it came out. That's how it worked out in the first class. So there's problem number 2. We had a question on problem number 3 as well. I had a nice little selection of problems here just to cover pretty much all the bases. The first problem had a function that intersected 3 times. Problem 2 had 2 functions that intersected in just 2 points, so there's just one area. And then this one has a combination of functions. And one of the reasons I was a little demanding at the start of the semester was problems like this. If you can understand what the graphs look like, it's so much easier to come up with everything that you need to come up with. So let's go back and review the graphs. The first graph is x equals 0. Well, all the points where x equals 0, I guess I'll use green to differentiate between my functions. There's the line, x equals 0. The next one is f of x, or y equals 125. Okay, 25, 50, 75, 100, 125. Here's the line, I'll put that up a little higher. Here's the line, y equals 125. Or f of x if you wish. Now the third function that's mentioned right here is g of x, and it's 25 e to the 0.01x. If you plug in x equals 0, you get 25. So it starts right there. And then the rest of the graph, it's an e to a positive power of x. That's our exponential graph. It has to go up like that. Now, even if you don't understand how this graphs, you should be able to put this fence in, x equals 0, okay? Now the next thing you'd have to do is find out where these two cross. So x equals 0, x equals 7, x equals negative 4, that's just a vertical fence. That's not going to move any place at all. But we need to come up with where these cross. So here's, I can tell there's the 1. Let's see if we can find that out. We're going to use algebra to find out where those two functions cross. Here's my 1 function. Let me make sure I've named it correctly. Yep, f of x 125. And g of x is equal to 25 e to the 0.018x. So what can I do to find out where those two functions cross? Okay, for A2 is also 4. So if you got a negative 4, there's something that you did somewhere along the line That wasn't quite right, probably with a negative sign. So how am I going to find the point where this function e to the 0.01 or 25e to the 0.018x is equal to 125? What do I have to do? I'm going to need some sort of limits on my integration from left to right. How do I find the place where these two functions cross each other? Ah, good. Okay. Good, Matthew. Really need to know that x value right there. And if I didn't have the graph, perhaps it could be over here. But how am I going to find it? I have to set them equal to each other. So we'll set 125 equal to 25e to the 0.018x. There's an equation we have to solve. There's only a single x in it. We should have the algebra skills to do that. What are the steps to solve that equation? What's the first thing we must do? Divide by 25, divide each side by 25, you're left with 5 is e to the 0.018x. So we need to know what power of e is equal to 5. What tool in our toolbox helps us figure that out? What do we do next? So we need to know what the power of e is that's equal to 5. What algebra function allows us to do that? Natural log, sure. Or you could, natural log both sides works, or you could remember the definition of natural log. I prefer really just going straight to what the next step is. When you have 5 is equal to this, the same equation can be written in natural log form. It's the natural log of 5 is e, oops, I'm sorry, natural log of 5 is equal to 0.018x. Natural log asks what power, so this is asking e to what power is equal to 5. Grab out the calculator, divide by this, and tell me what x is. Let's round to the nearest tenth. I don't think that comes out even. I think from my early class it was either 94 something or 89 something. I don't exactly recall. in my online calculator here that's handy, doesn't have a log function on it. 89.4. There we go. I like it. Right, so now we have everything we need to find the area between those two curves and this starting point. So again, we're going to allow our x vary. What is x going to vary for? From 0 to 89.4. Upper function minus lower function, dx, 0, 89.4. Okay, which is the upper? Well, in the graph, I can tell the 125 is higher than the exponential. If I didn't know, I could plug in any, the only time they're equal, by the way, is at 89.4. So I can choose any number before 89.4 because that's where any number in between here, I can even choose 0. If I plug in 0 here, I get this is equal to 25. G of 0 is 25. So if I don't have the graph, here's how I would proceed. And I choose f of 0. F of 0 is 125. And that's the bigger of the two. So my bigger function, my upper function minus my lower function would go like this. 125 minus 25 e to the 0.18x dx. And we did a problem almost identical to this one, it seems not all that long ago. Was it on the... Yeah, I guess it was on the pay rate one, where we had an exponential part. So let's take these separately. The antiderivative of 125 is 125x. Keep the minus sign, keep the 25, keep the e, keep the power. And then we'll multiply that by the reciprocal of the derivative of that. Is that 0.18 or 0.018? I'm going to go back and look. I don't want to mess up the decimal place. Yeah, 0.018. All right. So go back and make sure this is 0.018. And divide by 0.018. So we'll get a coefficient there. Someone with a calculator tell me what that coefficient is, please. That would pretty well wrap it up, huh? I guess that's when I can do it on my calculator. 25 divided by 1389 approximately. Whoops, left my X off. There we go. So plug in the 89.4. Figure that one out. I will plug in the 0 because it's easy. I'm going to subtract off. Plug in 0 here. That's 0. This is negative 1390 or negative 1389. So we'll have that first number minus negative 1389. That first number you get when you plug in 89.4. Add on that to 1389. And let me see if I had the answer key here a second ago. Let me see if I can find that back. Oh, there it is. So if you do that one correctly, it looks to me like it's somewhere around 5621 at the end. So there's an ending point for that one as well. Plug in 89.4 and tell me what you get. Well, it doesn't matter. You're going to get that, and you're going to add 1384 to it, and you should get somewhere around a 5621. Okay. Are there any more questions? So here's the quiz one more time. I give you, I think there are two problems. I'll give you a word problem first. I'll set out the words, then two definite integrals, and you have to describe what they mean in the context of the problem. And you must have the units correct as well. So that's sort of a review over what the activity was that was due today. And if you look at the problem with the intern, that'll guide you along the way as well. So we did all the problems we had except for problem number 2. Today's quiz will open up precisely at 4:45. You have until 5 o'clock to start it. If you want to jump off at 4:45 and take it, that's fine. If you want to see me do the last problem on the list, I'd be happy to do that. I'm sure we can wrap that up in 10 minutes. Your choice. You let me know. It's your 19 minutes. Your 19 minutes with me to spare. This is due Tuesday at the start of class, and I will have one more review session on Monday as well. My goal is to get all of my grading caught up over the weekend and start in on the exam number 4, which we'll have in class next Thursday. So any more questions? Look at the 1389 there, right? Sure, here we are off to problem 2. Problem 2 is probably the easiest of the 3 on there. We're just given 2 functions, and if they intersect, then if they intersect in 2 points, we'll have an area between them. If they don't intersect in 2 points, then we're not going to have any area in between them. So I'll draw a couple of ideas. If they don't intersect at all, maybe you have one function goes like this, one function goes like that. How are you going to find the area between them? There's not really a defined area. Maybe you could call it infinite, I suppose. If they intersect once, that's even a more difficult situation. You have 2 functions that intersect once. How do you define an area between them? I mean, which between do you want? But if you can find a function or 2 functions that intersect twice on their continuous region, and that's important as well, you can find something like that, then you have a sliver of hope of finding an area in between them. First thing I want to note on this one is problem 6, the g function 6 over x is discontinuous at x equals 0, so x can't be 0. If I find points of intersection, they both better be on one side of 0 or on the other, because this function doesn't even have a value at x equals 0. So let's see what we can do to find their points of intersection. And as always, we're going to find the points of intersection as we've done the previous 2 times by setting f equal to g. Get the right numbers for the right ones. It's 6 over x, and that's 7 minus x. So those are named correctly. And off we go. All right, I solved one like this on the practice video for today as well. Let's get rid of the x in the denominator. It's always best to get rid of the fractions. Multiplied by x, multiplied by x. 6 is 7x minus x squared. Hey, it's a quadratic. We've gotten good at those. Move everything to this side. X squared minus 7x plus 6 is 0. At this point, you can grab the quadratic formula if you wish, or you can try to factor. 2 factors of 6 that add up to 7 are pretty straightforward. X minus 1, x minus 6. Set those equal to 0 and solve. X equal 1 and x equals 6. All right, remember again that x equals 0, this one doesn't exist. We found 2 points where they cross that don't straddle that 0. They're both on the right-hand side of the graph. Now, I've been teaching math long enough. I remember, growing up, and really maybe within the last 5 years, pretty much everyone walking into this class was able to graph both this one and the 7 minus x. I think we've had some slippage along the way, but knowing that 6 over x looks like that is really handy. And noting that 7 minus x is a linear function with a slope of -1, that really helps as well. So I can sort of see what that was going to be before I even started the problem. Now, here's how I know if I get them right or not. So here's f, here is g. If I calculate f of 1, it should equal g of 1. And if I calculate f of 6, it should equal g of 6. If I plug in a 1 here, whoops, let me write it back up, 7 minus x. If I plug in a 1 here, I get 6, check. If I plug a 6 in each of them, I get a 1 and a 1, check. They both worked. How beautiful. Okay, so now I know that my integral has to be from 1 to 6. All I have left to do is take the upper function minus the lower function. The way I determine which is the upper function is either A, visually from my graph, or B, I choose some number in between those. Let me choose x equal 3 and see which is bigger. F of 3 is 6 over 3 is 2, while G of 3 is 7 minus 3 is 4. That is definitely the bigger of the two. So now my antiderivative, my definite integral, I should say, goes from 1 to 6. The bigger function, 7 minus x, minus the smaller function, minus 6 over x dx. Without a lot of ado on this one, I should be able to come up with the antiderivative. 7x is the function that has 7 for the derivative. Negative 1/2 x squared is the function that has negative x for the derivative. And minus natural log absolute value of x is the function that has 6 over, whoops, don't forget your 6. 6 natural log absolute value of x is the function whose derivative is 6 over x. Since 6 and 1 are both positive numbers, the absolute value plays no role. So there's not a lot of work left for you here. Plug in x equals 6, plug in x equal 1, and subtract the 1 from the other. So there it is, problem 2, really from start to the end. And that should wrap everything up. All right, so log out of internet for right now. Well, I shouldn't say that. So log into the quiz, have at the quiz. Any questions, email me over the weekend. If you're struggling still with the math editor, let's set up a session where I can see what you're doing and see what your screen looks like. Other than that, good luck on today's quiz, and I'll look forward to hearing from you soon. I'll certainly see some of you next Monday, 3 o'clock, for the next time we're together on YouTube.